Now in your lab, you were supposed to flip the coins 100 times. So 2 pennies 100 times to represent 100 offspring. Here you can see that I've flipped the pennies just a total of 10 times. But that'll at least give us an idea of the kinds of results and what you should have gotten. So in the 10 times that I flipped this, if you go through, you can count up and you can see that I have the genotype big S 1, 2, 3, 4 times. I have big S with little s 1, 2, 3, 4 times, and I have little s 1, 2 times. So if I list those probabilities out, my genotype results are here: 40% homozygous dominant, 40% heterozygous, and 20% homozygous recessive. That would give me the genotype ratios of 80% short big toes and 20% long big toes. If I then compare these actual results with the prediction of a Punnett square, it would look something like this. So my Punnett square says I should have had about 25% homozygous dominant, and I actually had 40%. Should have had about 50% heterozygous, and I had about 40%. I should have had about 25% homozygous recessive. I had about 20%. I should have had 75% with short big toe. I actually got 80%. The prediction is for 25% long big toe, and I ended up with just 20%. So I actually wasn't super close to what I would predict with a Punnett square, but recognize I only did 10 flips. And these predictions from Punnett squares are made on probability, and probabilities get better and better and better the more times that an event happens. So here's the class average data from about 150 student groups. So about 15,000 flips of the coin. And you can see that when you do that many coin flips instead of just 10, you get much closer to the predicted outcome. And if you flipped the coins a million times, this should be right at 25%, right at 50%, right at 25%, 75%, and 25%. It would be exactly what you predict with a Punnett square.